An amiable welcome to everyone. This is our Allied Lecdem channel to enhance your understanding. Today's topic is about ECG Basics, especially wave formation. Electrocardiogram. The term electrocardiogram can be splitted as electro means electricity, cardio means heart, and gram means visualize. An electrocardiogram is a simple test that can be used to check your heart's rhythm and electrical activity. There are two different types of cells in your heart. Number one, conducting cells, also called as pacemaker cells, muscle cells, also called as non pacemaker cells or myocardial cells. Cardiac action potential. The cardiac action potential mainly deals with the ionic channels of the cell. In the picture, you can see the positive charge in the extracellular space and negative charge in the intracellular space. The positive charge comprises of the ions sodium, calcium, and potassium. When the cell is in resting stage, which is the phase 4, called as resting membrane potential, the cell is more or less constant at roughly minus 90 millivolt, which is the threshold value. The cell is electronegative during resting membrane potential, and the cell waits for an impulse to change into next phase. Phase 0. After getting impulse, the sodium channel opens, resulting in influx of sodium ions into the cell. So, the cell automatically reaches positive value from threshold. Thus, the cell now becomes electropositive. In graph, minus 90 value is the threshold value. The arrow mark above it is influx of sodium. Rapid depolarization is the electropositivity of the cell. This phase continues until the sodium channel closes. Phase 1. After sodium influx, the sodium channels gets closed. This refers to as notch on action potential waveform. Phase 2. The normal healthy cell is rich in intracellular potassium and extracellular calcium. In this phase, both the potassium and calcium channel opens where calcium ions gets inside the cell and potassium ion gets outside the cell. But the cell potential is balanced, so it is also known as plateau phase. Phase 3. During phase 3, the calcium channel closes and potassium channel still remains open, which leaks potassium ions outside the cell. So the cell becomes electronegative and returns to resting membrane potential and waits for another signal to restart the cycle. This is the cardiac action potential. In this graph, influx of sodium is the phase 0, which is orange in color. Sodium channel closes is the phase 1. You can see a notch above the orange color, that is above the rapid depolarization. Slow calcium channel open is the plateau phase, that is the phase 2. Then calcium channel closes, potassium channel still remains open is the phase 3. Blue in color repolarization. The black line denotes the resting membrane potential, which is the phase 4. You can see the black line in minus 90 value and also at the end of the graph, which states the resting membrane potential. Gap junction. Till now, we only discussed the action in one cell. Each cell has gap junction by which it delivers or shares impulse. This is called electrically coupled. ECG machine. ECG machine works on a principle of galvanometer. Imagine the starting point of the tissue is connected to a negative pole and the other point is connected to the positive pole. When the cell is polarized state, there will be no potential difference is measured. So the cell remains neutral. Suppose when we provide impulse at the proximal portion of tissue and the other end is connected to positive pole. The positive vector moves towards the positive pole, which results in positive deflection, which is the upward deflection. This is called a wave of depolarization. When the entire tissue attains complete electropositive, there will be no longer potential difference. So the voltage will be zero, the galvanometer will be neutral, and the wave will be on the isoelectric line. There is a term called last cell in the ventricle to depolarize or the first to repolarize. When the tissue is repolarized, it becomes electronegative and the negative vector moves towards the negative pole, which provides the positive deflection. That is, negative into negative gives positive. A tissue have multiple cells. Each cell gives different vector, but the ECG machine picks up only the mean electrical vector, which is the sum of all vector. The voltage amplitude is directly proportional to the mass of tissue. For example, in atrium, it have a thin myocardium. These deflect only the weak deflection, that is the P wave. But in ventricle, it have thick myocardium and the deflection is much stronger than atrium, that is the R wave. Electrical event of the heart. For better understanding, kindly see our previous video about conduction system. Electrical event in the heart. It takes place by atrial and ventricle. The atrial event is divided into depolarization and repolarization. The depolarization of the atrium starts from the SA node. This node is present at the right corner of the right atrium. This is called pacemaker cell as it provides impulse for activation. These impulses activate each cell of atrium and the net vector will be downward leftward motion. That is towards the ventricle. When the positive pole or the electrode is placed near the ventricle and the negative pole or the electrode is placed near the SA. So the vector moves towards the positive pole. The deflection will be positive, that is upward. Due to thin myocardium in the atrium, the reflection will be weak. This phenomenon results in P wave. PR interval. After the atrial activation, the impulse moves towards the AV node, which is the only electrical window between the atrium and ventricle. This AV node is insulated by fibrous tissue, which is a bad conductor, and the cells in AV node are much smaller cells compared to the Purkinje system, which results in slow conduction. This delay in AV nodal conduction results in a isoelectric line in ECG wave, which is the PR interval. Atrial repolarization. This provides very weak deflection compared to ventricle, so this is negligible in P wave. Difference between AV node and Purkinje fiber. AV node have more cells and small cells, but Purkinje has less cell and large cells. AV node versus Purkinje fiber. AV node have more cell and small cell, whereas Purkinje have less cell and large cell. For example, just imagine there is a small block of tiles and big block of tiles. When we jump from one tile to the next in the large block, we can quickly reach the success line. But in small block, it takes much time. This example gives the clearance of fast conduction in the Purkinje system due to large cell and the slow conduction in the AV node due to small cell. The AV node have less gap junction, but the Purkinje have large gap junction, which results in quicker impulse transformation. AV node have more resistance because it is insulated, and the Purkinje have less resistance. The AV node depolarization depends on calcium channel and the Purkinje depolarization depends on sodium channel. Ventricular event. The ventricular event is also divided into depolarization and repolarization. The depolarization of the ventricle starts from septum, apex, and base. Q wave. After the impulse reaches the AV node, it delivers it to the bundle of His. This His bundle is also insulated like AV node. It is divided into left bundle branch and right bundle branch. In left bundle branch, at the end of septum, there will be a conduction gap. Through this gap, the impulse reaches the septum and it gets depolarized first. The vector here will be away from the positive pole, as the impulse starts from the end of the septum to the top of the septum. The vector is towards the negative pole, so it will be negative deflection. That is, the vector is towards the right upward and the negative deflection, which is the Q wave. R wave. At the end of the septum, there starts the apex. The myocardium is subdivided into subendocardial, subpericardial, and inner myocardium. This inner myocardium holds the Purkinje fiber. Among these, the first one to get the impulse is subendocardial myocardium. Then it reaches to subpericardium. When the impulse reaches the right bundle branch, it depolarizes the right ventricle. The entire ventricle gets depolarized and the resultant net mean vector is left downward, so the deflection is positive and strong. That is the R wave. This action is quick, so the R wave is notched. S wave. When the impulse travels to the basal part of the ventricle, the vector is produced, which is right upward. That is, it moves towards the negative pole and results in negative deflection, which is the S wave. Ventricular repolarization. After S wave, the cell nerve will be completely electropositive, so there will be no deflection noted. That is, the ST segment will be flat and noted on the isoelectric line. T wave. After depolarization, the cell starts repolarization. As I said before, the last cell to depolarize is the first to repolarize. The repolarization starts from basal part. The entire ventricle now became electronegative. When this negative vector moved towards the negative pole, listen, negative vector moved towards negative pole results in positive deflection. That is the T wave. Cardiac vector summarize. SA node, the vector will be left downward, which results in P wave as it moves towards positive pole. In AV node, the vector is neutral, so you can see the PR interval at the baseline. Q wave is negative as the vector moves towards the negative pole and the septum gets depolarized. When the ventricular is depolarized, R wave is produced. This vector is left downward and results in positive deflection. When the basal part gets depolarization, the S wave is produced, which is the negative wave due to negative deflection. When the cell is electropositive, ST segment is neutered, which is neutral in the baseline. When ventricle repolarization occurs, T wave is noted, that is, negative vector move towards the negative pole results in positive vector, that is the T wave. Thank you.